All right, diving deep this time, huh? You've sent me a ton of stuff on Mars. Like everything. History, missions, future plans, the whole shebang. Guessing you want the full Mars experience.
You got it. It's a wild ride, trust me. More twists and turns than, well, you'll see.
Uh, okay, keeping me in suspense. One thing that struck me going through all this is how many early missions just fail. The Soviet probes, then the 90s, all those mishaps. It's like there's a Mars curse or something.
Yeah, I get that. 60% failure rate back then. Pretty daunting when you put it that way. But gotta remember, we were flying blind for a long
Like
time.
trying to navigate by the stars before someone invented the sextant.
Like, perfect analogy. Each failure, though, gave us a tiny bit more information. Like, take Mariner 4 back in 65.
Mhm.
The images it sent back. Total game changer.
We thought Mars might be this Earth-like paradise. Then Mariner sends photos and it's craters everywhere. Not exactly inviting.
Nope, not at all. Shattered our assumptions. Mars was harsh, way more challenging than we thought. But that made the search for life even more interesting.
Because if life can hack IT there, that's a whole new definition of life altogether, right?
Exactly. And that brings up one of the most exciting things we have found. Evidence of water. Not just, like, billions of years ago, but maybe even now.
And that's the holy grail, isn't it?
Yeah.
Water means the potential for life, at least as we understand it. Where's the best evidence, do you think?
One spot that's really got scientists buzzing is Jezero Crater. That's where Perseverance is now. The data it's sending back is mind-blowing. Ancient river deltas, signs of flowing water. We're talking billions of years ago.
So like finding a fossil, but instead of one creature, it's a whole ecosystem frozen in time.
Great way to put it. But it's not all ancient history. Remember Odyssey? That orbiter mapped out huge deposits of water ice at the poles. And then there are the Martian gullies. Suggests liquid water might still flow near the surface, at least sometimes.
Okay, so water, check. But what about actual life itself? Are missions like Curiosity and Perseverance actually looking for that directly?
That's the billion-dollar question. But it's not as easy as spotting a dinosaur bone, right? Martian life, if it exists, might be microscopic, or something we haven't even imagined.
So how do you search for the unknown then? What are these rovers looking for specifically?
We're looking for what we call biosignatures, basically chemical traces that could point to life, past or present, specific carbon compounds, certain minerals, even just the ratios of isotopes in the soil.
I'm picturing like scientists huddled over microscopes, Martian dust spread out like a crime scene.
Haha, not far off. And each tiny discovery brings us a step closer to figuring out if we're alone in the universe.
So we've got water, the search for life. But what about the Martian climate itself? Everyone always pictures it as this cold, dusty, dead place.
Right, that's the common image, but it's way more dynamic than people think. The atmosphere is thin, sure, but it's not boring. We've all heard about those planet-wide dust storms, right?
Oh yeah, those are insane. How could a storm cover a whole planet like that?
Those storms are a key part of the Martian climate, and by studying them, we can start to model how that climate has changed over time. And there's a lot we can learn from the past.
Are you saying Mars wasn't always a cold, dusty desert? It could have been warmer and wetter?
That's the million-dollar question. Those polar ice caps we talked about, like a layer cake of Martian history, each layer holds clues to the planet's ancient climate.
Wow, okay. So it's not just about what Mars is now, but what it was. Which brings us to its geology. Is it just this barren, cratered landscape or what?
Oh man, you couldn't be more wrong. Mars has some of the most dramatic features in the solar system. Olympus Mons, giant volcano makes Everest look like a molehill, and Valles Marineris.
Uh-huh.
That canyon puts the Grand Canyon to shame.
Like Mars is flexing, even after billions of years. Didn't I read that it has a magnetic field too? What does that tell us?
You did. It does, though much weaker than Earth's, and a lot more localized. That weakness is actually key to understanding how Mars lost most of its atmosphere over time.
So a planet's magnetic field is like a shield, stopping the sun from stripping the atmosphere away.
Exactly. And the more we understand Mars's magnetic past, the better we understand its present, and maybe, just maybe, get some clues about what the future might hold. It's like, imagine a whisper versus a shout. Earth's magnetic field. That's the shout, deflecting most of the sun's energy. Mars. More like a whisper.
And that matters big time when we're talking about sending humans there, right?
Mhm.
It's not just robots anymore, it's about us.
You got it. And that's where things get even more interesting. We're not talking just planting a flag. We're talking about living there, long term, maybe even terraforming someday. But that weak magnetic field, yeah, that's a problem we gotta solve.
Because what good is colonizing a planet if you're getting fried by radiation the whole time?
Exactly. Think about it. Astronauts on the space station, they get about 10 times the radiation we do on Earth. On Mars, hundreds of times higher.
Oof, okay, that's a lot. So what's the plan? The lead vests for everyone.
Huh. I wish it were that simple. We're looking at all sorts of things. Shielding on spacecraft and habitats, for sure. Plus, designing new suits, better protection.
Like a high-tech version of those lead aprons you get at the dentist.
In a way, yeah. But honestly, the bigger challenge might be the mental aspect. Being cooped up in a tin can for months, traveling millions of miles, it does something to you.
Like the world's longest, most intense road trip. Except instead of annoying siblings, it's cosmic radiation. And probably freeze-dried ice cream for dinner.
You're not wrong. NASA's been studying this for ages, the psychology of it all. They even have those simulations, like HICs in Hawaii. Crews live in a Mars-like habitat for months at a time.
So, guinea pigs for future Martians, that's dedication.
It is, and they're learning a lot.
Mm.
Group dynamics, how to handle stress, even designing the spacecraft interiors to keep people sane.
Because when you're talking years-long missions, a new paint job ain't gonna cut it.
Yeah.
Speaking of, how are we getting there? What's the plan for human transportation?
Well, there are a few ideas floating around. NASA's got the Space Launch System, the SLS. It's meant to be the most powerful rocket ever, capable of sending humans and cargo all the way to Mars.
So like the heavy-duty moving truck of interplanetary travel.
Ha! That's a good way to put it. But then you've got private companies, like SpaceX, with their Starship program. Their goal is a fully reusable spacecraft,
Yeah.
transporting tons of people, supplies, the works.
I've seen those Starship test launches. Pretty wild. Lots of explosions, though.
Yeah, there have been some bumps in the road. That's how innovation works, though, right? Pushing boundaries, sometimes things go boom.
So we shouldn't be too worried about the fiery mishaps.
Not at all. It's all part of the process. And remember what we said earlier, we learn as much from failure, if not more, than from things going perfectly.
True, true. So whether it's NASA's Behemoth rocket or SpaceX's Starship, we're talking serious firepower to get us there. But then what? How do we survive on Mars? It's not like there's a Martian grocery store, right?
Right, which is where ISRU comes in. In situ resource utilization, basically using what's already on Mars to keep us alive.
So living off the land, Martian style.
Exactly. We're talking extracting water from the soil and atmosphere, using Martian regolith to make building materials, even generating oxygen from that thin air. It's like the ultimate recycling program.
Like the saying goes, when on Mars, do as the Martians do.
Well-
Except we're the Martians in this case.
Yeah.
But what are the biggest challenges with this ISRU stuff? Seems tricky.
Oh, it is. For one thing, that Martian atmosphere we talked about, it's about 100 times thinner than Earth's, and it's mostly carbon dioxide. Not exactly breathable, so we need ways to get oxygen for breathing, for growing food.
So super-powered air filters and greenhouses. Got it.
Yeah.
What about water, though? How do you squeeze water out of a planet that looks like a giant desert?
Well, there's evidence of water ice beneath the surface, especially farther from the equator. We could potentially drill down, access that ice, and purify it. Plus, that thin atmosphere still has water vapor we could extract.
Sounds like we're going to need some seriously smart people working on this. What about just building stuff on Mars? Wouldn't we need to ship tons of heavy materials from Earth?
Ideally, we'd ship as little as possible. The goal is to use what's already there, the Martian regolith. That's the loose dust and rock. Mix it with binders, create a kind of concrete, or even 3D print structures using specialized rovers.
Whoa, okay, so not your grandpa's construction site, more like robotic builders and 3D printed Martian homes. Starting to sound like a sci-fi movie over here.
Uh-huh, right. The future of Mars exploration is closer to sci-fi than we might think. But it's not just about tech, it's about the humans, too, making sure they actually thrive, not just survive.
Right, because Mars doesn't go easy on you. What are the long-term health things we need to worry about?
That's a huge one. Gravity, for starters. Mars's gravity is only about 38% of Earth's. Could lead to muscle and bone loss over time.
So it's not enough to get to Mars. You got to stay healthy once you're there.
Yeah.
What are we doing about that?
Scientists are looking at everything. Special exercise routines, maybe even dietary stuff. Some are even talking about creating artificial gravity, rotating habitats, centrifuges, that kind of thing.
Like those spinning spaceships you always see in movies.
Exactly. It might sound crazy, but it could be the key to keeping humans healthy on really long missions. But it's not just the physical stuff, right? Imagine the mental impact of living in a place so alien, so isolated. Yeah, it messes with your head, I'm sure. Visiting on a mission's one thing, you've got your objective, your team, your return ticket all lined up. But packing up, leaving Earth behind for good to build a whole new life, that's got to be something else.
Ultimate test of what humans are made of, right? Not just our bodies, but our minds. Are there any plans for how to, like, mentally prepare people for that?
Oh, absolutely. Psychological support is going to be huge EE. We're talking teletherapy sessions back with Earth, maybe even virtual reality setups that kind of mimic Earth environments, just to keep people grounded.
And I'm guessing picking the right crew is about more than just their skills, huh?
Hmm.
You'd need people who could handle it, but also people who'd work well together, right?
Exactly. Which brings up another crazy thought. What happens to society on a place like Mars? Lower gravity, limited resources, all those challenges. It's going to shape everything. Culture, government, even how humans evolve.
Whoa, yeah, okay, now my head's spinning. Were we talking Martian art? Martian music?
Right.
Martian laws? Will kids born on Mars even think of Earth as home?
Right. It's mind-blowing. We could see entirely new art forms inspired by that landscape, totally different social structures. And yeah, over generations, who knows what changes might happen.
It's like we'd be kicking off a whole new branch of humanity with its own culture, its own future. Pretty wild,
It's a grand experiment, no doubt. And like any experiment, there's risks. We talked about the tech stuff, the logistics. But what about the ethics of it all?
right? Because we're not sending robots with little scoops anymore. This is about human lives. And what if Mars already has life? Even if it's just microbes, do we have the right to just show up and change everything?
Those are the tough questions, the ones we have to ask. Do we have the right to colonize another planet? What if there's already something living there? Who gets priority? Us or whatever might be on Mars already? No easy answers.
Man, it feels like every answer about Mars just leads to more questions. But isn't that what exploring's all about?
It totally is. Mars isn't about finding all the answers. It's about asking the right questions, pushing what we know, questioning what we think is true.
Expanding our horizons, literally and figuratively. I like it.
And who knows? Maybe someday we'll look back at these early missions, all the robots we've sent, and see them as the very first steps towards humanity becoming a multi-planet species.
Not stuck on just one planet, but able to live all over the solar system. And maybe even beyond. Now that's a future I can get behind.
Right. It's a vision that really captures the imagination. Sure, there are challenges, things we don't know, but there's hope there too. Like, no matter what, humans just keep reaching for something bigger.
Well said. This deep dive on Mars has been incredible, really gets you thinking. We're on the edge of something huge EE here, something truly new for humanity.
We are, and the best is yet to come, I think.
I hope you're right. And to everyone listening, we leave you with this. What gets you excited about Mars? What do you think our role should be in this whole grand adventure? Whatever it is, keep exploring, keep asking those big questions, and never stop looking up at the stars. Who knows what we'll find out there?